Okay, let's go with name for now. And uppercase is going to be the proper type. Lowercase is going to be an alias. And that's important, not necessarily for string, because strings are strings, but if I do int foo equals 9, typically, if you are internal to your application, the alias is fine. But if you're doing an API, something you're talking to other systems, you want you want to actually say what the actual type is. And so now suddenly, we've got the option to do int16, int32, int64, unsigned 16, 32, and 64. So this is important because if you're talking to other systems that aren't C#, you want to be able to explicitly tell them, especially if you're doing like SOAP calls and a contract, to expect a very specific type in 16 or in 32, not just the any type of int, right? That's not gonna, if you're doing sensitive software with calculations, floating point calculations, you want to be very specific with the type of numbers you're sending over. Okay. Boop. So that feels good. Next I want to do find all inventory. So list of I inventory. I think that's going to work. I think. Let's say items equals room content dot game objects where x dot game object type is equal to game object types dot inventory item. Oops. And I'm going to select this as an I inventory item x dot toList. Man, all that red text was very scary for a second. All those red squiggly lines, it's got to power through it sometimes. Trust in thyself. Okay, so what did we just do? Link statements, very powerful. Lambda calculus, projections, lots of craziness going on. But super simple if we just look at it. And so I'm saying, hey, the room content has a list of game objects. So project over that list and return me back a new collection, IEnumerable, of game objects. This is where that hint we were showing before really helps out, because you can say, what am I getting back? What am I going to get back from this where clause? And it'll tell you, you're getting back an IEnumerable of iGame object. There's no black box here. You can always get that information. So even though you didn't explicitly say it, this hint is really powerful. So I'm saying, project over this and give me back a new IEnumerable, new collection of game objects that satisfy this condition. So give me all the game objects in the room that are of type inventory item. And then I'm saying, from that new collection, iterate over that, and for every game object, cast it to this IInventory item contract, take that collection, and give me a new list of type list, because it's an IEnumerable and I want a list, so I call toList. Whew. If you're new to Link, part of your brain just flew out the side of your head. But it's good to break it down this way, and I wanted to take the time to say this on video, so you have a point of reference if you want to come back to it. Alright, so I've outputted the monsters. And I'm going to clean this up a little bit in terms of the comment, because, and someone out there is going to kill me as far as doing this. There's going to be some purist out there that's saying the code should practically comment itself. Your code shouldn't look like postmodern art. But I think that because we're doing a video and you want to be able to get this clear, I'm going to make it easier for people watching actually see what's happening and that clear separation of activity. Alright, so I hope this helps. I output the title and description as far as drawing my room. I then find all players and monsters. I then find all inventory. Then I output the monsters. I output the players. Naturally, I think next I want to output the inventory. So I can pretty much just copy everything here. And if you've been following along, you're seeing another kind of red flag. You say, man, you were copying essentially the same thing 3 different times. That's probably a point to refactor. I may or may not get back all these red flags, but you if you are I assume if you're here, you're probably a junior to mid-level developer. This is where you can throw your hat in the ring. If you can at least identify these red flags, and you're trying to say to yourself, hey, where can I jump in on a project? Where can I add value? Here it is, right? Figure out the hows later, but just say, point of refactor, I'll take that task, I'll clean this up for you, and then go hit the books and learn how to actually do that. Ask some questions. Ask questions while you're young, right? That's the advice your parents will give you, no matter how old you are. 40 years old, parents will still prattle on to you. So, take this chance and say, I want to figure out how to refactor this, and bite it off and see what happens. Okay. On the ground. And I'm running out of colors because console is, well, it's just the console. There's no really way to get around it. Let's do gray and see what happens. White. Oh, so I've changed the foreground color, so this will turn out to be gray on the ground. The foreground color, I'm changing it back to white, and then I'm going to output, let me just change the string up here to be consistent, and then I'm going to output the inventory. Hang on, what did I do? Oh, items, sorry. Items.name. And I can confidently call name because in the same way that we were saying before, hey, look, every object in C# has a toString method. We created our own very low level object, which is the game object, and we made sure that everything in the game has a name. So no matter where you are, you can always rest assured that you can call item.name and get a result. Let's build this. Succeeded. Let's play it. Ooh. On the ground, 2 things, but they don't have names. For shame. For shame. Alright, so let's see why that is. Go into our inventory. Okay, we've got some classes. We decided to differentiate and say that player inventory items, and this is where we use the bridge design pattern, to say that player inventory items would be something that's just a little bit different than other items in the game. And doing some concrete implementations. Man, we wrote a lot of code. Ooh. So in none of these am I returning back the name. How about that? Let's break some rules, y'all. So I'm going to do this 3 times. Oops, no, I'm do it here. Okay. So in my abstract player inventory item, and only for player inventory items, so you can see I've got a base inventory item that's back over here in my other folder. That's my abstraction for the bridge design pattern, so that in different domains you can surface this new idea of an inventory item that doesn't have to conform directly to the overall concept of inventory items. I know it's a bit tricky, the bridge pattern's weird, but you'll see here I just want player inventory items to this kind of hacky thing. So I'm going to do public, I'm sorry, what am I doing here? Oh. So, protected player inventory item. So in the constructor, I'm going to do name is equal to type of this dot name. Will that work? I don't think it actually does. Oh, so it's even hackier. It doesn't care what this is. I forget what language I'm in sometimes. I'm like, oh, JavaScript, this is it's so great. Man, this might actually be a little dirtier than I want it to be. I would love to just use the reflection to get the name of the class and get it back, but well, I do have a less hacky name test hammer. Okay. I was going to do something hacky, and I think I still could, but I don't want to waste too much time. Like, I shouldn't be spending a lot of time showing you guys how to do hacky stuff, I don't think. Okay, so test hammer name equals fist. And I think this is fine because in the real game you would want all of these items to be inside of a database, so that as you're developing the game, you'd have your own admin interface where you can just in a form, and you can just very quickly add new items to the database. You don't want to have to because a world could have hundreds of items. You don't want hundreds of classes. We're doing this here because we want to have one seed room, right? One room that's going to work no matter what. No database, no connection, no whatever, doesn't matter. I can always generate my little divine chamber where anything's possible. Test out new weapons, slaughter innocents. Doesn't matter. It's your room. It's your world. Do whatever you want. Okay. Name test charm. So fist, hammer, test charm, wearable. Okay, so we got some names on there. Oh man, the hour runs quick. So I got to wrap up here in a second, but before we take a break for a few days and come back to Refactor Saturday, let's at least see what we wanted to do. And I might implement this behind the scenes. I might not. I might save it for Saturday, but these hours move so quickly.